solution of pair of linear equation in two variables. So now we are looking at pair, not a single one. So what does solution mean when it comes to pair? To understand this, we can take up two ways. One is algebraic and another is geometric way. So to begin with, we need equations because we are talking about pair. So we need equations, two of it. So I have two of them, right? And I have set of numbers over here, order pair. So this is also called as order pair. So what you can do is substitute each of this value, and for equation 1, check out if it's true or false. It will give you a true or false statement. For equation 2 too, you should do the same. So make a list and then post that. You can guess or you can talk about solution for pair of linear equation. Right, we can discuss that. So now you have to pause the video and try out putting different values over here and checking out if it's true or false. So to begin with, if you put 0 and 0, we have 0, 0, minus 10 and 0. So this is a false statement for equation 1. 0 and 0 plus 4. So 4 is equal to 0. This too is a false statement. Next is minus 5 and minus 1. Minus 5, minus 1, and this is also negative. So this is all negative terms. False statement. Minus 5, okay. Minus of minus 5 is plus 1. Sorry. Minus of minus 1 is plus 1. 5 plus 1, sorry, minus 5 plus 1 plus 4 is 0. So this is a true statement. I hope I didn't confuse you guys. For x is equal to minus 5 and y is equal to minus 5. Sorry, minus 1. I'm taking equation 2. Sub into. So we are looking at minus 5 minus of minus 1 plus 4 is equal to 0. So this is minus 5 plus 1 plus 4 is equal to 0. So this is 0 is equal to 0, and this is a true statement. Then we have 3 and minus 1. 3 minus 1 minus 10. This is all negative terms. I mean, you'll get a negative answer. So this is false, right? 3 and minus 1. So 3 minus of minus 1 is plus 1. So all these are positive terms. So this also is false. Then we have 2 and 8. 2, 8 is 10. 10 minus 10 is 0. So this is a true statement. 2 and minus 8 over here, right? Because this is 8 and this is, when you substitute it, it will be minus 8. So this will be negative 6 plus 4, a negative term. So this cannot be 0. So it is a false statement. So now pause and think which is your solution amongst all of these values. Clearly, first and the third one can't be. So we have a true over here and a true over here. So what do you think? Are these two your solutions for the given pair of linear equation? Well, these are also not the solution for given pair of linear equation. So what exactly is the solution for these two pairs? So, and how do we find it? How do we find it? To answer that question about how to find, so we're doing that in the entire chapter, how to find the solution. So we're not looking at that, but we'll be looking into the graphical meaning of a solution and thus find the answer for this particular question. Okay, so let me clear this. I need the space. Let's look into the graphical meaning of solution of pair of linear equations. So for that, I need to open my code, and we have the code over here. Okay, so we'll look into the details a bit later, but we'll just make use of it and generate our graph. So we have the first equation. The coefficients are, I guess, 1, 1 and minus 10. Yes, it is 1, 1 and minus 10. And the next one is 1, minus 1 and plus 4. 1, minus 1 and plus 4. and we have our graph. Okay, so we are looking at the equation 1 being represented by green line and the equation 2 being represented by the red line. So graphically, what does it mean to have the solution for both the lines? It is nothing but that point wherein both the lines are crossing. In this case, that is, let's zoom in to see what is it exactly. It looks to be 3,7, sorry, 7,3. Okay, so basically, graphically, what it means is the point wherein both the lines crosses each other. That's what graphically it means to have a solution, right? Graphical meaning of a solution is the point, in some cases points, where the lines crosses one another. If not cross, touch is also okay. They just touch and go. Right? This is a general meaning. It's for linear pair they generally cross. For not generally cross, they will cross if they do cross. And for other graphs, I'm talking about quadratic or cubic or so on and so forth, there is a different possibility. So, but yeah, the definition holds good even there. So we found that 7,3, I guess. Yeah, 7,3 was a solution. Well, does it make sense algebraically? Okay, I should not be putting x over there. I should be solving it. So let's substitute the value. 7 plus 3 is 10. 10 minus 10 is 0. So in this case, we got a true statement. 7 minus 3. Sorry, wait. Am I reading it wrong? Oh yeah, I was reading it wrong. It is 3 and 7. 3 and 7. So 3 minus 7 is minus 4. Minus 4 and plus 4 is 0. So here too we have a true statement. It makes sense. But how come, what about this values, minus 5, minus 1 or 2,8? I mean, it's making sense to one but not for the other. Why is it so? So let's have a look at that. We have 2 over here and 8 will be upper. Right? So 2,8 is a point. 2,8 is a point wherein the green line is passing while the red is not. That's why it makes sense that equation 1, which is the green line, it's true for the equation 1 but false for the equation 2. So solution for pair of a linear equation in two variables is that value or values. In some cases you will get more than 1 point. That will be looking in the chapter itself. So that value which will be true, which will give you a true statement for both the equations. Okay, of course it can be not only pair, it can be any number of linear equation. It can be more than 2, So basic idea is solution for any number of linear equation is that value which makes all of those equation, when we substitute with that value, to give a true statement. You take any other value, it won't give. Right? Whenever they're crossing, you take any other value other than the, in this case 3,7. You take any other value, it might satisfy one but not the other. So that's the whole idea about solution of pair of linear equation and the geometrical meaning behind it.